let's look at some more of the stuff. Last little pieces here for 6.1 is, now that we know all these attributes, can we use them to find some measures? Because that's the big thing in geometry. Can you measure it? The sum of the interior angle measures of a convex 11-gon. It's important that it's convex, because for it to be convex, or for us to calculate it, we need to know that. Otherwise, it could be virtually anything. So the polygon angle sum theorem is something we can reference here. But let's see what's actually happening. Let's start with a shape that's similar. How about 5 sides? So here's a 5-sided figure. Here's a 6-sided figure. Let's start looking at those. If I were to start splitting these up into triangles, notice that I can split this 5-sided figure up into 3 triangles. If I were to do the same thing to the 6-sided figure, this one would be 4 triangles. So I have 1, 2, 3 triangles. 1, 2, 3, 4 triangles. Well, to find the total angles inside, if I were to add up all 3 of these angles, and this angle, and these angles, and these angles, and this one, that would give me the sum of all of them inside. But notice that I can kind of regroup this. I can do part of this angle with purple ones. And I can do, let's say, red ones for these parts. And how about green ones for the last ones? If I do each of those, the purple, the red, and the green separate, I should get the same total as if I did just all the blue. And that's how it works. So I can split it up into triangles and just add up the number of triangles inside. So each triangle is worth 180. This is 1, 2, 3 triangles. 3 times 180. This next one is 1, 2, 3, 4 triangles. So that's 4 times 180. A quick note about drawing these triangles. Notice that I started them all at the same vertex. That does kind of matter. Otherwise you start getting a little bit picky and you might have overlap, and if you crisscross triangles and you start counting angles on the inside that didn't really make the same amount of angles, or angle measure. So this first one, 3 times 180 would be, what's that, 360 plus another 180. 3 times 18, that's 9 times 6, 540. Trying to do too much in my head here, and you start writing this down. 4 times 180, that's 720. So if I'm doing an 11-gon, I need to see this pattern. Why is this saying -2? Oh, well, check this out. I can connect to this one and this one, making a diagonal. But notice that I can't make a diagonal over to here, and I can't make a diagonal over to here. I can't make those last 2 diagonals because I'm already connected. Because I'm already connected to these on the outer perimeter. Same with this other one. That's going to take 2 possibilities away. So I have to take my total number of sides and take away 2 of them. So when I'm looking at an 11-gon, I want to figure out how many of the, what's the sum of the interior angle measures. I'm going to subtract 2 and then multiply by 180. So this next one, it says a dodecagon. Well, dodecagon is 12 sides. That means 10 triangles. That means 10 times 180, which equals 1800. It's that easy. The measure of each interior angle of a regular, that seems important, regular 20-gon. Well, if it's regular, that means all angles are congruent. So I got this 20-sided figure, and I want to figure out what the sum is of the interior part, but then I want to figure out each one. Well, if I have 20 angles, and they all add up to something, I could find one of them. I just got to divide it by 20. Well, first let's figure out what the total is. The total, that's going to be 20 sides, therefore 18 triangles. So it's going to be 18 times 180. If I wanted to figure that out, let's give ourselves some more space here. 18 times 180. 0, 64. 8 times 6 and 1 is 14, so 1440 for there. And I got 180 to add on to it. 0, 4, 2, okay, 1, 3240. Now, that's the total. But what did it want? It wanted just one angle. If I'm trying to find one angle then, what I should do is take the total, which is 3240, and divide that by the number of sides that there are, or the number of angles. I should be more specific, the number of angles. It's the same, but it matters. So 20 goes into 32 once. We got 12 left over, 124. 20 goes into 124 6 times. That gives me 120. 20 goes into 40 twice. So each angle would be 162 degrees. Not too bad. So when we're finding the total, you just got to figure out how many triangles. The number of triangles tells you the total interior angles. But if it's a regular polygon, then we can figure out how much each one is because they're all the same. Then we can just say that they all add up to whatever the total is. Let's try some more. Now if we're looking at exterior angles, this is a little bit different. What we find when we do an exterior angle, let's go ahead and take some shapes here. Let's start with a pentagon. If I have a pentagon and it's not even exactly as is, if I were to make exterior angles off each side here, that looks like one, and this green one, and then let's do another one, let's say a red one.